This is Steve Piloff from George Mason University. Let's look at some more examples of finding a payment associated with an annuity or annuity due when we're saving future value. So in 4 years you want to have 25,000. So in 4 years we want to have 25,000 in order to buy a house. Done a decent job getting started. We have 4,000 saved currently. How much you need to save each year for 4 years. So we know we're going to be putting in 4 payments because we're going to be saving each year for 4 years. Equal amount each year. First savings is in 1 year, and you can earn 12% per year. So there's our first, second, third, and fourth. We can earn 12%. So what we're looking for is what is C such that 4,000 times 1.12 to the fourth plus C times 1.12 to the third plus C times 1.12 squared plus C times 1.12 plus C is equal to 25,000. And so one way we can approach this is to say, okay, we know the future value of all 5 of these terms has to equal 25,000. So let's figure out 4,000. What will that compound to? Then take the difference, and we know that that's what these guys have to compound to, and then we just find the payment associated with an annuity with that difference. So we know that 4,000 invested at 12%, that 4 years later it would compound to $6,294. Therefore, the regular payments need to get us the other $18,705.92 in order for us to achieve our goal of 25,000. And so now we just have to find the payment associated with the 4-period annuity due that'll get us to $18,705.92. And so if there's 4 payments and they start in 1 year and their future value is $18,705.92 and we can earn 12%, then each of those payments is $39,1392. So you start with 4,000, and then in 1, 2, 3, and 4 years, each of those years you put in $39,1392. When you go in 4 years to give your last $39,1392, and you say, here's my check, now can I have all my money? The bank will give you 25,000. But notice, n equals 4 because there's 4 payments, n equals 4 because, oh, I'm sorry, n equals 4 down here because there's 4 payments, n equals 4 up here because the amount of time from the 4,000 saved to when we want to know the future value is 4. So n's got its 2 functions, it's 4 in both cases. We can just do it in one step. So n equals 4, we want to have 25,000. We start with 4,000. It increases, compounds by 12%. Therefore, how much do we need to save if we start in one period each year in order to get 25,000, given that we're starting with 4? And the answer is $39,1392. Here's a similar situation. We want to have 25,000 in 4 years, but we currently have nothing saved. How much we need to save each year for 4 years? Equal amount each year, first in a year, so we got those 4 payments. We can earn 12%, but we're also going to make an extra payment of 4,000 in 2 years. So the reason it's positive is because 4,000 more is going into our account. That gets to compound to help us get to 25,000. So here, the 4,000 compounds for 2 years, 1, 2, to get from 4,000 to, or to get from time 2 when we make it to time 4 when we want to know how much money we have. So in this case, n is 2, n is 4, n is 2 for the extra, n is 4 for the 4 payments. So we have to do it in 2 steps, where we'll figure out, okay, 4,000 compounds, and how much will it be in 4 years? And then we know that these regular payments have to contribute to the rest. So as I noted before, you've got 4 and 2, and that's going to be our approach. So let's attack this problem. If we make a special extra payment of 4,000 in 2 years, and again, since we're making it in 2 years, and we want to know how much we'll have in 4 years, it'll be invested for 2 years. from 2 to 3 and from 3 to 4. So 4,000 times 1.12 squared would get us roughly $5,018. But our goal is 25,000, and therefore the 4 regular payments that start in 1 year have to contribute 19,982.40. So what we want to do is find out what's the payment associated with a 4-period annuity, because we start in 1 year, that has a future value of 19,982.40. So if the 4 regular payments gets us 19,982.40, we know that the 4,000 in 2 years gets us 5,017.60. We'll have our 25,000. So there's 4 payments. They start in 1 period. We can earn 12%. We need them to accumulate to 19,982.40. There's nothing else, because the else gets taken into account separately, which is what got us the 1992.40, and we'll see that we need to save 41.81.01 every year for 4 years starting in 1 year. So 1 year we go to the bank and give them 41.81.01. 2 years we go to the bank and give them 41.81.01 plus an extra 4,000. 3 years we give the bank 41.81.01. 4 years we show up, we say here's 41.81.01 and please give us our money, and they will give us $25,000.